Watch these two jumps. Same character, same gravity, same jump button. The one on the left feels broken, you press jump right at the ledge and nothing happens. The one on the right feels amazing, it launches every single time, even a hair too late. Nothing changed but the code. That gap has a name. It's called jump feel, and by the end of this Phaser 3 tutorial you'll code all 3 tricks the pros use. One quick, honest heads up before we open the editor. If you want more finished games to pull apart after this, I put together a Phaser game dev bundle. $19, 10 complete browser games with full source you can reskin and ship. It's completely optional, the link is in the description, and it never interrupts the tutorial. Now, let's build a platformer. Every Phaser game starts with one config object, the control panel for the whole thing. Type is Phaser.AUTO, so it uses fast WebGL and falls back to canvas on its own. Width and height set the game size in pixels. Then physics. We pick the arcade engine, simple, fast, perfect for a platformer. And here is the line that makes it a platformer instead of a top-down game, gravity, Y, 800. That pulls everything with a body toward the floor. Debug false keeps the collision boxes hidden, flip it to true when you want to see them. Finally, scene is an array with our play scene. One line boots it, new Phaser.game, pass the config, done. That's the entire startup. A platformer needs a level. The professional way to build one is a tilemap, you paint it in the free tiled editor and export it as JSON. Phaser loads that straight in. In preload we load 3 things. The tileset image, the picture of all your tiles. The map itself, with load.tilemap.tiled.json, a key and the path to the exported JSON. And the player, as a sprite sheet, so we tell Phaser each frame is 32 by 32 pixels. Now build it in Create. Make tilemap with the map key gives you the map object. Add tileset image links the tileset's name inside tile to the image key we loaded. Then create layer draws the actual ground layer on screen. And here is the one line that makes it solid, set collision by property, collides true. In tiled you mark your solid tiles with a custom property called collides. This tells Phaser, only those tiles stop the player. Empty sky stays empty. That's your whole level, and it collides. Now the player. One line drops it in. This .physics.add.sprite takes an X and a Y for the start position, plus the player key. Because we used physics.add, it comes with a body that gravity can pull and walls can stop. Set collide world bounds true draws an invisible wall around the level edges, so the player can't slide off into nothing. Then the important line for a platformer, this .physics.add.collider, the player and the ground layer. A collider is the solid connection, it's what actually lands the player on the tiles instead of falling straight through them. Last, we grab the keyboard. This .input.keyboard.create cursor keys wires up all 4 arrow keys in one call. It hands us back up, down, left, and right, ready to read every frame. A sliding statue isn't a platformer, so let's bring the player to life with animations. Because we loaded the player as a sprite sheet, each frame has a number, and we stitch them into named clips. This .anims.create, key run, and generate frame numbers pulls frames 0 through 5 off the sheet. Frame rate 10 plays them at 10 a second, and repeat -1 loops it forever. Idle is just one still frame, frame 6. Then in update we read the keys. If left is down, set velocity x negative, flip the sprite to face left, and play the run clip. Right is the mirror image. And if neither is pressed, stop, and play idle. That true as the second argument means don't restart the animation if it's already running, without it the clip stutters on every frame. Now the player runs, faces the right way, and rests when you let go. Now jumping, and this is where most tutorials stop, and where games start to feel cheap. Here's the obvious version. First we check the ground. On a platformer you read this .player.body.blocked.down. It's true when the body is pressed against a solid tile below it. Then, if the up key is down and we're on the ground, set velocity y to -500, and up we go. It works. But play it and it feels stiff, and there are two reasons why. First problem, run off a ledge and block down flips to false, so a jump you pressed a frame late just gets eaten. Your fingers were right, the code was too strict. Second problem, every jump is exactly the same height. Tap the button or hold it down, you get the identical hop. There's no control, no lightness. Let's fix both, starting with that ledge problem. The first fix is called Coyote time. It's named after the cartoon Coyote who hangs in the air a moment before he falls. The idea, for a tiny window after you leave a ledge, the game still lets you jump, as if you were on the ground. It's a countdown. We keep a number on the player called Coyote. Every frame, if we're on the ground, we refill it to 100 milliseconds. If we're not, we drain it by delta, and delta is the second argument to update, the milliseconds since the last frame. So the moment you step off a ledge, Coyote starts counting down from 100 towards 0. Then the jump check changes. Instead of blocked down, we ask, is Coyote still above 0? We also switch to Phaser.input.keyboard.justDown, which fires exactly once on the press, not every frame it's held. Press jump within 1/10 of a second of leaving the edge, and it still launches. Ledge jump stop failing, and it feels forgiving in the best way. The second fix is jump buffering. It solves the opposite problem, pressing jump a hair too early, a moment before you land, and having it ignored. Fast players do this constantly. Same trick, other direction. We add a second countdown called jump buffer. When just down fires, we don't jump immediately, we set jump buffer to 120 milliseconds, remembering that you asked. Every frame, jump buffer drains by delta 2. Now the actual jump fires when both timers agree, jump buffer greater than 0 and Coyote greater than 0. Then we zero them both so it can't double fire. Read that together, you pressed jump recently, and you were on the ground recently. Press just before you touch down, and the instant you land, the buffered jump goes off. Combined with Coyote time, the controls now feel like they read your mind. Last trick, and it's the one players feel without ever knowing why, variable jump height. Hold the button, get a full leap. Tap it, get a small hop. That single thing is most of what makes a jump feel good. It's 4 lines. Grab the up key and the player's vertical velocity, remember, up is negative, so a rising player has a negative y. Then, if the up key is now released and we're still moving up, cut that upward velocity in half. Set velocity y to velocity y times 0.5. That's the whole thing. Release early and you kill the rest of the rise, so you barely leave the ground. Keep holding and the velocity is never cut, so you get the full jump. Coyote time, jump buffering, variable height, 3 small pieces of code, and your platformer suddenly controls like a real one. Let's lock it in. You built a real level from a tiled tilemap and made it solid with set collision by property. You dropped in a player with a physics body, landed it on the ground with a collider, and gave it run and idle animations. And then the part that actually matters. You took a stiff, cheap-feeling jump and added the 3 tricks the pros use. Coyote time, so ledge jumps forgive you. Jump buffering, so early presses still fire. And variable height, so a tap is a hop and a hold is a leap. That's a platformer that feels good to play, not just one that works. If you want the every line written version, it's free in the description, with a copy button on every block. Next up on the channel, take these same physics into a Phaser top-down shooter, different genre, same skills. And if you want 10 complete games to reskin and ship, the Phaser Game Dev Bundle is $19, full source, link below. Subscribe for more build-alongs, and go make something you can send a friend as a link. See you in the next one.